Alright guys, so this is the first video of the aircraft simulation series using Ansys Fluent, and I have here the workbench window. Let's start with that. For the way I am carrying these simulations, I'm gonna simply start by dragging the geometry tab here, and now I'm gonna show you guys what the geometry looks like in SolidWorks. This is the aircraft we're going to be using for this model, and you can see that it's just a half body because we are going to use a symmetric boundary condition here in the middle. And an important remark is that I have simplified the geometry and I have rounded up the trailing edge, which is a good practice to have when you're running CFD simulations with aircraft. You don't want to have like super sharp edges because that can lead to some problems with very high cell skewness in close to the trailing edge areas. So in order to eliminate that issue, I just rounded up the trailing edge, which is a reasonable thing to do. Even if you manufacture the airplane, you will never have like a perfectly uh, sharp trailing edge um, unless you go there and send it by yourself, but probably nobody's going to do that. Um, so yeah, rounded up trailing edges, and what I'm going to do is actually save, this is a SolidWorks solid part. I'm going to save it as IGS. That's my favorite format for opening it in Fluent. I'm not going to hit save because I already have it, but you can do that at home. Now moving on to Workbench with a geometry setup, I'm going to come here and import a geometry. And I'm just going to import the geometry that I had saved previously. And I edit it in Design Modeler. You could use Space Claim. I just prefer Design Modeler, just personal choice. And once Modeler pops up, all you gotta do is change to material, um, because if you leave it as frozen, that's considering that the geometry is fluid, which it isn't up to now. And we have the exact same thing. Now what I'm gonna do is actually I'm gonna choose a plane to start a sketch, and we're gonna build our fluid domain around this solid body. To do that, I just choose the ZX plane and I start a sketch. And in this sketch, I'm gonna draw the outline of an ellipse, or a quarter of an ellipse, and I do that by creating two lines here, one to the front and one towards the back of the airplane, and of oops, and another line here at the yes, here towards the top of the screen. And now I choose the ellipse. This is going to be the center. I drag it up to here and to the front. And now what I do is I trim uh, the excess lines, which would be these, and then I'm left with the outline of our half bullet uh, domain. I'm gonna add some dimensions. This is gonna be v1, v2, and H3. And here I'm gonna put 13 meters for each of them. Now, this is a very big domain. Um, I'm following the recommendations for external aerodynamic simulations of aircraft. Um, it's recommended. Well, there's a lot of divergence uh, of what an adequate fluid domain size would be, and uh, I'm going with like 25 times the maximum body length. Uh, this airplane has a maximum body length of roughly zero point 0.5 meters, half a meter. So if you multiply that by 25, that's like 12.5. Um, but since it's not exactly half a meter, I'm just like rounding it up to 13 meters across all the directions. So 13 to the front, 13 to the back, and 13 maximum maximum height here. And hit generate. And now what I have to do is to use this sketch to revolve. And I select this axis and change this. This is important. Change it to frozen because this is going to be fluid and not a material. And here I'm going to change to 180 and reverse it because it has to be revolved to that side. And hit generate. Now I can hide the sketch, and this is the overall geometry of the fluid domain. So now one thing, an important step is to actually, because you can see that you still have two bodies. You have the first body, which is the aircraft, and you have the second body, which is the fluid domain, and they are separate. We don't want that for the simulation. So what we're going to do is actually subtract the aircraft body from the fluid domain. And we do that by creating a Boolean. We change it to subtract target body is this one. And the tool body is the airplane. Here. Hit generate. And this is what we have. We have the fluid domain that has this shape, and the airplane walls are embedded in the fluid domain. So the flow, when we run the simulation, the flow will have to go past, uh, go around these walls. As a last step, we're going to create named selections because that's important for the next step, which would be the meshing. And we do that by, you select this selection to go to the, let's go to this to the middle surface, and this is going to be our symmetry. We have our inlet here, and we have our outlet here. It's nice to name them with the with the names that they are, because that helps Fluent to recognize the kind of boundary conditions that we're going to apply to them. And here the last one would be the wall. Um, what I like to do is, instead of selecting all of the walls manually, I like to use this tool. So first off, I select pressing Control, and I select a few of the surfaces, and then I just use this little tool, extend to limits, and then all of the tangent surfaces are selected. That way I make sure that I'm not missing any of the surfaces that need to have like the wall boundary condition. This geometry is pretty simple, so it wouldn't be a lot of trouble to select manually all of the surfaces, but think about when you have like a more complex geometry where you have like dozens of surfaces. That tool is very useful in those cases. So we apply the, well, not apply, we name this the wall. You can see there's 7 faces in total and hit generate. Okay, so yeah, this concludes our geometry setup. And you can see that now we have our fluid domain and our 4 named selections. And now we are good to go to the next step, which would be the meshing. And we do that by, we go here to, well, let's use Fluent with Fluent meshing. And we're going to establish this connection here. Basically, it's seeding, it's, feeding the geometry into the meshing of this module. And I'm just going to give this a name. Uh, let's come here. I'm going to create a folder test. This is going to be our test simulation. And that's it.